Welcome to Frog Dissection. Here's our little friend. See if I can open his mouth. Oh, he's not opening. What's up? We're going to start with the outside of the frog and talk about why the frog's body looks like this and how it's adapted to the environment that the frog lives in. If we look at him, we can notice his head is really streamlined, or her. We're not sure what she is yet. And look at the legs. Get these big fat legs because those are the muscles underneath there. If you eat frog legs, that's what you eat. Look at those feet. They've got special webbing in the feet for swimming. So they've got these big strong legs for swimming, swim, and jumping. And then take a look at the head. If the frog was in the water, they kind of sit like this. And just sticking out of the head, out of the water, is their eyes and their nose. And the water line kind of cuts across this round thing, which is their ear. Because think about what the frog needs to do. He wants to eat, and he wants to avoid being eaten. So with his head above the water, he can breathe here through his nostrils. He can see, looking for food. If you look closely, there's a special membrane there. It's called the nictitating membrane. It's like a built-in swim goggle that the frog has, so he can see underwater too. And then the water line's going to go right across here so he can avoid predators that are in the water and outside of the water. And we also look at his coloring. He's spotted. These are leopard frogs. It's also called a grass frog. You can see because of the spots. And think about what the frog's natural environment. It's not bright blue like the dissection tray. It's swampy and messy. So he blends in this way. The frog also spends a lot of time swimming on the top of the water. And look how light underneath it is. Now, this guy's been dead for a while, but he would be white normally. So he would blend in for the upper sky. So if a predator underneath, like a bass or a turtle, is looking to chow on him, he would blend in. So we call that double camouflage for him. The hands are not webbed. You might be able to see a little knob on there. That's for traction, so if he jumps up on a rock or a log. If he was a tree frog, those would actually be suction cups, so he could hold on. First thing we're going to do is look inside his mouth. The mouth, I need the probes. I'm going to open the mouth up so you can see what the inside mouth structures look like and the tongue. In order to do that, I've got to actually dislocate his jaw with the scalpel. Hopefully, Mrs. Conley won't stab herself doing this. There we go. There we go. So I just popped that lower jaw of the mandible right out. And I'm going to do this side. Because I'm left-handed, it's harder for me to do this side. It's actually not pretty easy. There we go. And we've got the mouth open. So here's his tongue. Now, a lot of times when we're doing this in class, people are like, stretch it out, stretch it out. Well, frog's dead, so the tongue is a muscle, so it's in rigor mortis, so we can't stretch it. But you can notice it has kind of those two prongs on the end. And normally that tongue would stretch out way out from his mouth, because what he's going to do to capture his prey, open that mouth up. Am I doing it right? Open the mouth up, and that tongue would go out and grab whatever he wants to eat. And then it's sticky, and he flips it back up, and he actually skewers it into special teeth that are in the roof of his mouth. There's two little teeth there. Frogs don't chew their food. It gets squished up in that whole process. They don't chew their food, but they swallow it whole. And you'll notice if you look at a frog that's alive, when they swallow, you can see their eyes go up and down. If we look back inside it, you can see these little bulges. And again, it doesn't work because the frog's dead. Oops, there's some food in his mouth. Oh, look at that. They actually use their eyes to swallow, so that the eyeballs push down and the food goes right down the back of his throat. Also in his mouth, you can see those are where the nostrils go. So that connects out to the front. Maybe. Not quite going. And down in the back of his throat, there's two openings, just like we have two openings. One goes down to his esophagus, and there's a little round muscle there that goes to his lungs. So just like he needs to be able to open and close that, because when he's in the water, we don't want water in the lungs, and he doesn't want food going down the wrong pipe, just like we do. So that opens and closes when he's ready. Okay.
Now, if we found a frog outside, Mrs. Connolly, could we dissect it?
No. These frogs have been specially processed. The blood has been taken out of them, and they've been preserved. That's why we don't see blood. You might see, you know, it's wet because of the preservative that's inside it, but we don't want it to hurt any froggies that are outside. These frogs have been specially bred so we can use them in science. I did also pull out of its mouth, I don't know if you can see it. It looks like some kind of beetle part right there was actually still in its mouth, and we'll see when we open them up if we have any other bug parts in here. So now I'm going to actually start the dissection and start by taking off his skin first. I'm going to use forceps, I forgot to bring them. Okay. And I'm going to do a sideways clip there. And slide the scissors in. We're going to cut the skin off. We're going to go this way and cross. So I use the scissors and go right up. It's a little bit tougher up here. We do have to cut pretty high because his sternum is there that's protecting his heart, and there's some connective tissue that's holding that skin in. So I'm just going to cut that away and cut down this side. Frogs are able to, they get most of their oxygen through breathing, gills when they're tadpoles that you guys learned about the other day. They also can get some through their skin, and you can see it's kind of light, but there's some blood vessels in their skin. When they're down underwater, they can actually get some oxygen right directly through their skin into their blood vessels. So I'm going to cut this skin right off. There it is. Do the other side.
Oh, I can hear it tearing. Now, Mrs. Connolly's being very careful when you do this because you want to make sure you don't cut through the muscles underneath. You'll see this frog has awesome abs.
Yes. There we go. Look at the abs on that froggy. Abs of steel. That's his abs. This is his pectoralis muscles, the chest muscles. And it's hard right there because that's where the frog's sternum is. Frogs are easy to dissect because they don't have ribs that come around the front like we do. They do have a backbone. They're a vertebrate like we learned about. And they're small, teeny kind of ribs that come off of here that make its back, but it does not come around the front, which is one of the reasons we use frogs to dissect with so we can easily get into it. Now to get into the frog, I'm going to do the same cuts that I just did. I'm going to cut the muscles down here. Whoop, look at all that fluid in there. And again, that's not all that is the preservative that the frog's in. And I'm going to cut up right through that middle line. There's a big blood vessel that comes off of the aorta there. That's that dark line. And to get into it, I got to cut way down the side. Way down this side. And you can see, I'm starting to get into some organs. There's the intestine right there, and that gray thing is the liver. We're going to get a little bit closer to that. We can't see the heart yet because it's up under the sternum. So I've got to cut up the skin up, or the muscle up a little bit here. And then I'm actually going to cut through the bone of the sternum. You're going to hear a click. Here we go. Crunch.
For most students, I think that's probably the most difficult part, is when they have to cut through the sternum.
Oops, jeez.
Uh-oh, splash.
Splash. So I'm getting into the heart now. I don't know if do we have the right light? The light part is the ventricle of the heart, so we can see it. We can't quite see all of it yet, so I'm just going to do some more work to cut away some of this tissue, connective tissue that's protecting the heart, and cut down along the sides. I don't want to spray Mrs. OH.
Thank you.
Hey.
Have you ever had frog's legs?
Yes.
Do they taste like chicken?
Yes. Except I had them, they were in spaghetti sauce, so it was kind of hard to tell. I had them in Montreal, no, Quebec City. All right, I'm going to do the same thing on this side where my scissors go. All right. So now we've got Froggy open and we can see most of his organs at this point. If we go through it, we've got his heart is there It's still kind of protected by the pericardium. You'll notice that muscle, remember the ventricle is the strongest part of the heart, the muscle part of the heart, cardiac muscle. So that's the same color. The darker part up here is the atrium, so that has more blood in it. This big 3 thing is the liver. So the liver is processing things for the frog. And if we lift that up, underneath it, that green blob is the gallbladder. So the gallbladder makes the bile, the liver makes the bile, the gallbladder holds it to processing, and those are all connected to the intestine. So the frog's stomach is here. There's the stomach, and it connects around to the small intestine. We're going to take that out and look at it closer in a sec. And the large intestine where the poop is there. That black thing is the spleen, and this stuff is the fat. This frog appears to be male. So I don't see eggs in it. I can see this curly thing is this testicle. That's where the sperm would be made. And this gray thing back here is the lung. He's dead, so his lung is collapsed, but that would be a ballooned up, and there'd be one on the other side. And back beneath there is the pancreas. So I'm going to cut out the liver so we can get a better look at the stomach. And we're going to see if our froggy had anything else to eat. Now, we already saw a bug part in his mouth, so.
What's the coolest thing you found inside your frog, any of the frogs that we've dissected over the years?
I think the coolest thing that we found in these frogs, we had a scorpion one time.
Oh.
Was that in your class or mine? I can't remember.
I think that was in your class. I think
It was pretty cool.
Yeah.
But we found lots of bug parts. I mean, this stomach looks pretty big. If I put the probe down his throat, can you see I'm moving the probe in his stomach right now? So it went right down into his stomach. So I'm going to cut the stomach off, and so we can look inside it and see what it looks like.
So what is all the fat? I see all the yellow banana-looking finger-like things in there. What is the fat used for?
So the frog eats and eats and eats. There goes the stomach.
Kind of like me during this pandemic.
Yes. And so when he hibernates, that's the food that he lives off. This guy has quite a bit of fat in it. So I would guess that he was probably killed in late summer, fall, because he's got a lot of fat that he lives off. When we open them up and they have little fat, that's usually they've used that fat supply up while they're hibernating. I'm just cutting connective tissue here, and I'm going to cut the large intestine down close to what the cloaca, where the poop goes out. And I'm just cutting connective tissue because we're going to lift this intestine all the way out. Oops. Let me take a look at it. So remember that the small intestines, one of its main jobs is to absorb nutrients. And when we look at this, there's the small intestine, and you can see blood vessels there in the middle. That's where the nutrients are being absorbed so the frog can use it. I'm gonna cut the intestine off of the stomach, and we'll open the stomach up and see what's inside.
The stomach looks pretty big for a frog, but I imagine our stomachs would not be as big compared to our size. Maybe that's because the frog doesn't chew.
And the stomach looks pretty big, but there doesn't appear to be anything in there. But you can see our stomachs look just like this. See those ridges that are in there? That's the muscles that churn up the food for mechanical digestion, and your stomach looks like that too. When our stomach growls, it's those muscles that are going, that's looking for food. So now I'm going to do the intestine. I'm just going to cut this connective tissue.
So if you were to compare the length of the intestines to the frog's length, they're pretty much about the same size. But if you were to compare our intestines to our height or length, our intestines would be somewhere, as an adult at least, 5 times as tall as we are.
Yeah. So there's the intestine. Again, it doesn't appear to have, it's got some fluid in it, but it doesn't have a lot. That's the small intestine and the large intestine. So the large intestine has the poop in it. I'll make it poop. Yay, poop, frog poop. That's on my finger. And again, so it ate something for lunch, but I'm not exactly sure what. Sometimes we can see little bug parts in this. Like that is something, but I'm not sure what exactly it is. There we go. When I was in college at UNH, we dissected big bullfrogs, and one time they had little baby frogs inside the bullfrogs because they ate another species. All right, so that's pretty much it for the intestinal tract. So if you think about it, guys, they have all the same organs that we do, but it looks a little bit differently. Think about when we think about differences between it. Number one, how do they catch their food? Do frogs, we most of the time don't eat live food, do we? But the frogs prefer live food, so they'll catch insects, or they might catch small fish, or they might worms they like, and they'll do that and eat it and process it. But the rest of the dissectant is pretty much similar. I mean, their system is similar to what we have. They have lungs. When they're born, you know, we studied this the other day. They're born as eggs, and the eggs have to be in the water because they don't have a shell. And then they hatch out, and the tadpole is called the larval stage, and they have gills, and they have tails, and they swim around, and then they evolve. They go through complete metamorphosis, so the adult looks totally different from the babies. So once we get the fat in here, that's a kidney, I believe. Oh, that's a lung. No, that's the pancreas, I think. And that's about it. We can see where I can stick the probe in his mouth. Oh, there it is now. I took out his stomach so he doesn't have it. And again, it's a boy. That's where the sperm would be made. And that's about it, guys.
Can we take a look at the ear?
Yep.
They say you can tell by looking at the ears if the frog is a male or a female, but I never could.
I never could either. Supposedly, and I think it's more common on bullfrogs than these guys, supposedly on the male, if you look at a bullfrog, the tympanium, that's what the ear is called, that's the eardrum, is bigger than the eye. But on the leopard frogs, we don't see that. You can see that swim membrane pretty good on this side. There it is. All right. So please email us, guys, with any questions that you have, anything that we didn't cover, and we'll still be learning about frogs and toads and the difference between amphibians and reptiles coming up in the next couple days. And we're going to have you questions on it. It's all good. Thanks, guys.